Hi, grade 11. So today we are starting chapter 5. We're switching gears now, and we're going over to trigonometry. So lesson 5.1 is trigonometric ratios of acute angles. So there's actually no handout for this one. The lesson was just quite short, and I just found it was easier just to write notes. So if you just grab a blank sheet of paper and take some notes, and that should be good for this one. So first we're going to start by reviewing the trigonometry that you learned in grade 10. So in grade 10, you learned what was called the primary trig ratios. And you'll remember the primary trig ratios as SOHCAHTOA. So we'll just first review what those are. So this only works for right triangles. So if I have a right triangle ABC, and I look now at angle A, so we're only talking about angle A right now, then I can label this triangle using the terms opposite, adjacent, and hypotenuse. And these refer to the side lengths that are opposite angle A, adjacent to angle A, and the hypotenuse of the triangle. So the side length that is opposite angle A would be this one here, between B and C, because it's not touching angle A at all. The side length that's adjacent is the one that's touching, but it's not the hypotenuse. Okay, so that would be this one here, adjacent, and then the hypotenuse is always the longest side, and it's always opposite the right angle. So it's the one that's not touching the right angle. Okay? So using SOHCAHTOA, we recall that SOHCAHTOA means sine, so we'll go A, we'll use A here. Sine A equals O is for opposite over H for hypotenuse. Cos A, we're looking at the second section, equals A for adjacent over H for hypotenuse. And then tan A equals O for opposite over A for adjacent. So we can use this to calculate either missing angles or missing side lengths if we're given enough other information. So something new that you didn't learn last year are the reciprocal trig ratios, which we're going to talk about now. So those were the reciprocal trigonometric ratios. And I'll just give you a definition of those. The textbook definition is reciprocal ratios are defined as 1 divided by each of the primary trig ratios. So there are 3 reciprocal trig ratios, and they're just the reciprocals of sine, cos, and tan. So the first one is called cosecant. And cosecant has a short form, which is CSC. So we would do the same thing as we did with sine. We would put an angle behind it. So sine A or sine B or sine C. We're going to use A in this situation. So cosecant A is equal to 1 over sine A. So instead of being sine, which is opposite over hypotenuse, it would be the reciprocal, so we would flip that to be the hypotenuse over the opposite. All right, so cosecant is the reciprocal of sine. So it's 1 over sine, flip that fraction is the reciprocal. Okay, the next one is called secant. And the short form for that is SEC. So secant A is the reciprocal, or 1 over cos A. And you'll remember that cos A is adjacent over hypotenuse. So secant would be hypotenuse over adjacent. And then the third one is cotangent. And the short form for that is COT. So cotangent A is equal to 1 over tan A, which is equal to not opposite over adjacent, but flip that to be adjacent over opposite. right? So these are the 3 reciprocal trig ratios. These ones back here are the primary trig ratios, and altogether we say that these are the 6 trig ratios. All right, so now we're going to do an example and practice using these. So, example, determine the 6 trig ratios for the following triangle for angle A. So if I give you this triangle here, and I have a right angle, because this only works with right triangles, side AB is 6, side AC is 10, and side BC is 8. Okay, so now we are looking at angle A here. So we need to find the 6 trig ratios. So we'll first start with the primary trig ratio, so sine, cos, and tan. So sine A, I'll just write SOHCAHTOA here, so we can refer to it. So sine A is equal to opposite over hypotenuse. So the side length that is opposite to A would be 8. And the side length that is the hypotenuse would be 10. So sine A equals 8 over 10. This is a fraction that can be reduced, so we'll do that, and that's equal to 4 over 5. All right, so sine A equals 4/5. Now, cos is adjacent over hypotenuse. So adjacent to A is 6, and the hypotenuse again is 10. That fraction can also be reduced. That would be 3/5. And then tan is opposite over adjacent. So opposite, we already said, was 8, and adjacent is 6. Now we can reduce that to be 4 over 3. Okay, now cosecant is the reciprocal of sine A. So sine A was 4/5, so cosecant A is 5/4. Secant A is the reciprocal of cos A, which was 3/5, so secant A is 5/3. Cotangent A is the reciprocal of tan A, which was 4/3, so cotangent A is 3/4. So see how easy that is? That's just the reciprocal, but this can be really useful when we're solving word problems. So now I would like you to determine, the value of angle A and C in that same triangle. So I'll draw it again. It's a right triangle, A, B, C. The side lengths are 6, 10, and 8. And we need to find what angle A is and angle C. So angle A, looking at that again, you can choose if you want to use sine, cos, or tan. I'm going to use sine in this case. So sine A equals, remember, SOHCAHTOA, sine opposite over hypotenuse. So opposite was 8 over hypotenuse was 10 equals 4/5. So sine A equals 4/5. Now you'll recall from grade 10 that when you're missing the angle, but you have what it equals, you will use the inverse. So sine inverse of 4/5 equals A. So grab your calculator, find the sine button. You'll probably have to hit shift to get sine inverse, and then brackets 4 divided by 5, and you should get 53.13 equals A, and that's degrees. So angle A is 53.13 degrees. Now angle C, we can choose sine, cos, or tan, whichever one we like. And in this case, I'm going to use cos C. And cos C, so looking at angle C now, cos is adjacent over hypotenuse, so adjacent would be 8, and hypotenuse is 10, so that also equals 4/5. So now we're going to do cos C equals 4/5, so therefore angle C equals cos inverse 4/5. You always use the inverse if you have a missing angle. And type that into your calculator. Shift cos bracket 4 divided by 5 bracket equals 36.87 degrees. Now, you could also find angle C by doing 180 minus 90 because we know B is 90. And now that we know A is 53.13, you could do it that way because we know that all three angles in a triangle add up to 180, and you would get the same answer as well. But I just wanted to show you that this method here works using the three primary trig ratios as well. All right, so there's just a couple more things I want to show you. If a question asks you to find cosecant 20, or another one of the reciprocal ratios, that's not on your calculator. You can't go to your calculator and find the cosecant button. So that's when you need to know that secant equals 1 over sine 20. So cosecant 20 is the reciprocal of sine 20. So that equals 1 over sine 20. And then you could type that into your calculator. So you'll go 1 divided by bracket sine 20 bracket equals 2.92. All right? So you just need to know the three reciprocal ratios and how they match up to the primary trig ratios so that you can solve these types of questions. Okay, and then what about if you need to calculate a missing side length? So if I have a triangle, that's a right angle, and this is 5, they tell me this angle is 39 degrees, and they say find H. So I have to use angle 39 here because it's the only one I know. Now I need to ask, which two sides am I dealing with? The hypotenuse, opposite, or adjacent? Which of those two? Which two of those three? Hypotenuse, opposite, or adjacent? So I'll look at this angle, and I have the adjacent, and I have the hypotenuse. Okay, so now I need to look at SOHCAHTOA and say which primary trig ratio contains adjacent and hypotenuse, and that would be cos. So therefore I'm going to use cos. Cos 39 equals adjacent, which is 5, over hypotenuse. So I need to solve for h, so I need to get h by itself. In order to do that, I'm going to multiply both sides by h. Those cancel out, so now I have h cos 39 equals 5. Divide both sides by cos 39. H equals 5 over cos 39. Punch that into your calculator, and you will get 6.43. So the hypotenuse is 6.43 centimeters, or whatever it is. Or the other way you can do this is you can say cos 39 equals 5 over h. So therefore, secant, which is the reciprocal of cos, secant 39 equals h over 5. Multiply both sides by 5. Cross that out. So 5 secant 39 equals h. Secant 39 is the same as 1 over cos 39. So now you'll do 5 over cos 39 equals h. Punch that into your calculator. It's the same thing. 6.43 equals h. We did exactly the same thing. There was just a different order of steps. Okay, so either of those are options. Sometimes the question will say use a reciprocal trig ratio, and then you would have to do it this way rather than with the primary trig ratio. All right, and then just two more things. Some of the word problems will say the angle of elevation is 42 degrees. So just a reminder, you did learn this in grade 10, but just a reminder, the angle of elevation is you start at the horizon line, the angle of elevation is up from the horizon line, so it would be this angle here. And then the opposite of that would be the angle of depression or declination. And again, start with the horizon line and you're going down, it's this angle here. Okay, so just always remember, start at the horizon line and then elevate or decline from there. All right, so just a quick lesson. So that's it. Let me know if you have any questions, and hopefully you do well with the homework questions.